To make it easier to understand, the video you see here is the product of polyethylene or PE, a star player seen in a plastic bag. PE is a versatile and widely used thermoplastic polymer. It is part of the polyolefin family and is created through the polymerization of ethylene molecules. This process results in a material with excellent properties, making it indispensable across numerous industries. One of its primary attractions is exceptionally flexibility, durability, and chemical resistance, which make it cornerstone in various sectors. It is significant spans industries like packaging, construction, transportation, healthcare, and even in everyday consumer products. For the first one, bulk polymerization method as applied to a polyethylene product, there are several process works in the manufacturing of the polyethylene. Catalyst preparation. The preparation of a catalyst system is the first step in the procedure. Ziegler-Natta catalysts are transition metal compounds supported on a carrier that are commonly employed in bulk polymerization. These catalysts are extremely effective at the initiation of the polymerization reaction. Next is reaction vessel. The polymerization reaction takes place in a reactor or a tank constructed to resist the high pressure required for this approach to preserve specific reaction condition. The vessel is sealed. Next one is initiation. Along with the ethylene monomer, the catalyst system is put into a reactor. The catalyst functions as a catalyst, causing the polymerization reaction to begin. Ethylene molecules begin to link together, resulting in the development of polymer chain. Polymerization. The polymer chains continue to develop as the reaction advances by joining with the more ethylene molecules. This results in the formation of longer chains, which create polyethylene. Control condition. Precise temperature and pressure control throughout the process is essential for improving the polymerization reaction. This control enables for the modification of the resulting polyethylene's molecular weight and characteristic. Next is termination. By altering condition or introducing substance that deactivate the catalyst, the reaction is halted at the desired stage. This effectively halts further polymerization. Next is product recovery. Once the reaction is complete, the polyethylene is usually extracted from the reactor. It undergoes purification and processing to yield various forms such as pellets or granules, suitable for diverse applications. Next, we move on to the fundamental principle. Bulk polymerization for polyethylene involves initiating the polymerization reaction in the absence of solvent or diluent, allowing the monomer to polymerize in its pure, undiluted form. The fundamental principle of bulk polymerization for polyethylene emphasizes the use of catalyst, high pressure conditions, controlled temperatures, and the absence of the solvent or diluents. This principle enables the efficient production of polyethylene with tailored properties suitable for diverse industrial applications from packaging, construction, to automotive and healthcare sector. Catalyst initiation. Catalyst plays a pivotal role in bulk polymerization. Ziegler-Natta catalyst consisting of a transition metal compound supported a carrier are commonly used. These catalysts efficiently initiate the polymerization reaction by activating the ethylene molecules to start forming polymer chains. High pressure and temperature. Bulk polymerization typically require high pressure conditions, often in the range of several hundred atmospheres, to encourage the initiation and progression of the polymerization reaction. Additionally, elevated temperatures are necessary to activate the catalyst and accelerate the reaction kinetics. Control environment. Precise control of reaction conditions, including temperature and pressure, is crucial for controlling the molecular weight, structure, and properties of the resulting polyethylene. Maintaining these parameters within specific range ensure the desired characteristic of the polymer. Next, propagation and termination. Once the polymerization is initiated, ethylene molecules combine to form polymer chains through a process called propagation. The reaction continues until terminated. Termination occurs when the catalyst is deactive or when certain chemical agents are introduced to stop the polymerization process at the desired molecular weight or stage. For product recovery and processing, after the reaction is complete, the polyethylene is typically extracted from the reaction vessel. It undergoes purification and processing steps to remove any residual catalyst or impurities and is then shaped into a various forms. For example, pellets, granules, and suitable for a different application. For the advantages, simplicity. Bulk polymerization doesn't require a solvent or diluent, simplifying the process and reducing the additional separation step. Next is controlled molecular weight. The process allows for good control over the molecular weight of the polyethylene produced, which influence its properties and application. Lastly, efficient catalyst usage. Catalysts used in a bulk polymerization tend to be more efficient, reducing catalyst usage and potentially lowering production costs. Disadvantages: uniformity challenges. Achieving uniformity in a polymerization throughout the bulk can be challenging, potentially leading to a variation in the final product's properties. Next is limited to a certain grades. While it's suitable for producing high-density polyethylene, bulk polymerization might not be as effective for certain specialist grades or type of polyethylene. Lastly, equipment complexity and cost. The reactors and equipment need to handle high pressure, high temperature condition can be complex and costly to set up and maintain. All the examples I will show is illustration and versatility of HDPE produced through bulk polymerization, showcasing its use in various products across industries due to its durability, chemical resistance, and other desirable properties. The first one is HDPE packaging films. The application is the packaging films for food and non-food items. For this example, we will use for the pipes. And the HDPE containers and bottles, the application is packaging for chemicals, detergent, oils, and other liquids. The HDPE is chemical resistant and durability make it an ideal material for containers that need to withstand a variety of contents. The last one is HDPE pipes. The application is municipal water supply, gas distribution, industrial pipelines. The reason why is the HDPE pipes are known for their strength, durability, and resistance to corrosion, making them suitable for transporting liquids and gases.
Okay, hi, Assalamualaikum. My name is FAZIANIE BINTI MOHAMAD SHOKRI. I'm from RAS 1133A. Today I want to proceed my part is a solution polymerization.
Okay, what is solution polymerization? Solution polymerization is a method in industry polymerization. In this procedure, a monomer is dissolved in a non-reactive solvent that contains catalyst and initiator. In this reaction result in a polymer which is also solid in the chosen solvent.
In solution polymerization, there are a few methods to produce PE in this addition polymerization. Number one, monomer along with initiator dissolved in water solvent form polymer stay dissolved. Number two, the mixture is kept at polymerization temperature and constantly against it. Number three, it depending on concentration of monomer, the viscosity of solution does not increase.
Next, after the reaction is over, the polymer is used in the form of polymer solution or the polymer is isolated by evaporation the solvent. And lastly, the polymer form can be used for surface coating and it can use to produce another polymer. Next, the principle and conditional of solution polymerization. Number one is monomer and initiator must be dissoluble in the liquid and the solvent must have the desired change transfer characteristics and the boiling point. Number two is the polymerization temperature. Polymerization temperature is between 50 to 100 and the time given is 20 minutes. Polymerization period 60 minutes. Okay, next, in addition polymerization, there are a few advantages and disadvantages for using solution polymerization for PE. For the advantages is the solvent acts as a dilute and help in facilitating continuous transfer of heat of polymerization. Number two, the solvent allows easy stirring as in decreasing the viscosity of reaction mixture. Next is the disadvantages of using solution polymerization for PE. The disadvantages is it given polymer of a high molecular weight. Polymer cannot be formed as the solvent molecular and it may act as a chain termination. Number two, this method can give a smaller yield of polymer per reaction volume as the solvent wastes the reactor space. Lastly is the product and application involving solution polymerization for PE. Okay, the product produced is nylon. Okay, application of nylon is it produce the nylon thread and it can produce a fabric nylon and it can use for fabric for umbrella too.
Next addition polymerization is emulsion polymerization.
What is emulsion polymerization? Emulsion polymerization is a polymerization process with different application on the industrial and academic scale. It involves application of emulsifier to emulsify the hydrophobic polymer through aqueous pasta by emphatic emulsifier, the generation of free radical with either water or oil soluble initiator.
Next, for emulsion polymerization, they have a few methods to produce PE. Number one is the monomer is dispersed in the aqueous pasta and not discrete droplet, but it has uniform emulsion. Next is number 2. Number 2 is about the size of monomer. Size monomer droplet in around 0.5 to 10 micrometer in diameter depend upon the polymerization temperature and rate of aggregation. Number 3, the immersion of monomer in water is stabilized by surfactant. Number 4, the surfactant have a hydrophilic and hydrophobic end in the structure. And next is number 5. When it put into water, the surface molecule gather together in aggregates called micelle. Number 6 is hydrocarbon tails is called hydrophobic, is orient inward, and the head is hydrophilic, is orient outward into water. Lastly is number 7. The monomer molecule diffuse from monomer droplet to water and from water to hydrocarbon to the center of micelle.
Next is the principle and factor involved in immersion polymerization. Number 1 is monomer. Number 2 is solvent initiator. Number 3 is emulsify agent. And lastly is diffraction medium. Advantages and disadvantages for this addition polymerization. Number 1 for the advantages is if given high molecular weight for polymer, and it can be fast polymerization rates. And lastly, it allows to removal of heat from the system. Next is for disadvantages. The disadvantages is a surfactant and polymerization adjuvants different to remove. And next is for dry. It removal is energy intensive process. And lastly, it cannot be used for conditioner and ionic process. Next, there are a few product and a few application by this polymerization in PE. The product number 1 is printing inks. The application of printing inks is used for means of information or decorative purpose in printed media, and it can be catalogs and article of their life. And lastly, the product is paper coating. Paper coating is used for advertising material, book, and high quality of catalogs. That's all for me. Thank you.
Next is suspension polymerization. Suspension polymerization is a heterogeneous polymerization that will give a porous polymer particles to the final products. As a result, this process gives a high-performance polymer beads used in most specialized applications. Method of suspension polymerization in polyethylene production. First, water-insoluble monomers initiator and a chain transfer agent are mixed with the help of agitator. The initiator then is soluble in the monomer, and both are immersible with water. The immersible liquids are concentrated into suspensions of microdroplets of diameter 0.1 mm. The polymer is obtained in the form of small beads which can be easily collected. Solvent is removed and the polymers obtained are pure. Polymers can be sometimes soluble on their own that lead to have a jelly-like formation. Lastly, it can be overcome by adding stabilizers like PDA and attrition. Aspect in suspension polymerization. There are two categories. First one, liquid phase. Liquid phase contains free radical initiator, chain transfer agent, plasticizers, and rubber modifier. Second one, solid phase. Solid phase contains granulating agent and water-soluble polymer, or known as suspending agent. The advantages of suspension polymerizations are inexpensive and environmentally favorable, easily isolated in insoluble water, and the polymers obtained are pure. The disadvantages are time consumed is high to obtain a high molecule mass polymers, and only water can be the insoluble solvent. These are some applications of suspension polymerization. Lastly, gas phase polymerization. Gas phase polymerization is a method most used in polymer production. The heterogeneous reaction between gas monomers and solid catalysts using a fluidized bed reactor to process the products. This is the difficult method due to the involatile polymers tend to condense out of the phase. Method of gas phase polymerization in polyethylene production. First, growing polymer particles are fluidized by a recycled gas stream containing polyethylene monomer, hydrogen, and nitrogen. The feed gas well containing the monomers with a catalyst serves to agitate the bed and fluidization through the distributor. The heat of polymerization then is removed from the reactor. The cooling of the recycled gas which exits from the top of reactor is important to keep the red-out production of polyethylene. The temperature needs to be above the dew point to avoid condensation, and also keep it below melting point to avoid particle melting. The principle and conditions of Gas phase polymerizations are its complicated production, heat and mass transfer, and also complex gas and solid. The advantages of gas phase polymerizations are it's better in heat removal, work at much lower temperature and pressures, and need only a little solvent. The disadvantages is take a long computational times to fully exploit the models. This is the application of suspension polymerizations.
Bulk polymerization and solution polymerization is a homogeneous reaction, and for the bulk polymerization, a soluble radical initiator is added to a pure monomer in a liquid state, and the reaction is carried out in the absence of any solvent or dispersion. And for the solution polymerization, the monomer is dissolved in a solvent, and the reaction is initiated by heating or exposure to radiation. Suspension polymerization and emulsion polymerization is a heterogeneous reaction. Both involve the use of solvent to dissolve the monomers and facilitate the polymerization process. This tends to stabilize the reaction of monomer. The size of the polymer particles can be controlled. And for the suspension polymerization, the initiation is located in the monomer phase and more suitable for application requiring a specific particle size or shape. For the emulsion polymerization, it is more suitable for application requiring high molecular weight, and the initiation is located in the water surface. Bulk polymerization and solution polymerization is a homogeneous reaction, and for the bulk polymerization, a soluble radical initiator is added to a pure monomer in a liquid state, and the reaction is carried out in the absence of any solvent or dispersion. And for the solution polymerization, the monomer is dissolved in a solvent, and the reaction is initiated by heating or exposure to radiation. The bulk polymerization process is that it is simple and requires thermal insolution, and the polymer obtained is pure. Large casting may be prepared directly. So for the weaknesses, the heat involved during chain growth reaction may cause the reaction to become too vigorous and difficult to control. Emulsion polymerization, it can produce emulsion polymers which can be used as a solid simply by drying. The polymerization occurs in the water phase, enabling the generation of particles with specific characteristics. For the weaknesses, the initiation is located in the water phase, which may limit the types of polymer that can be produced. Solution polymerization, it can produce polymers with controlled molecular weight distribution. It also can be used to separate specific polymer by using a non-solvent for the remaining polymers. But presence of a solvent lowers the actual rate of polymerization in the mixture, and complete removal of the solvent is difficult. Polymerization, the absence of liquid phase in the polymerization zone. This process is a continuous zone carried out in a fluidized bed reactor. And for the weaknesses, the absence of a liquid phase may limit the types of a polymer that can be produced. For the suspension polymerization, the strength is that the monomer conversion is usually complete, unlike bulk polymerization, and the initiation used in this process is monomer soluble. And for the weaknesses, there is a possibility of a monomer droplets sticking to each other and causing creaming, which needs to be prevented by a careful stirring or the addition of a protective colloid. Next, we are going to move on the suitability of each method for specific application in the industry. For the bulk polymerization, it can be used in the production of crossing and thermosetting polymers such as those used in the automotive and construction. For the solution polymerization, it is suitable for application requiring polymers with a narrow molecular weight distribution such as high-performance plastic and advanced materials in the aerospace and electronic industries. For the emulsion polymerization, it is suitable for application requiring production and easy processing of PE products such as disposable items, packaging materials, and textiles. For suspension polymerization, the application requiring high conversion levels and the production of high-density polyethylene or linear low-density polyethylene products such as pipes, films, and automotive components. For the gas phase polymerization, it is suitable for application requiring high-density PE products such as pipe, films, and automotive components. For the summary, gas phase polymerization is advantageous for polyethylene production due to its ability to produce common thermoplastic polymers. This method offers the advantages of not requiring any diluent and the absence of a liquid phase in the polymerization zone, making it suitable for large-scale production. Additionally, it is used to produce high-volume resins and polymers that are stable in the gaseous phase. For conclusion, each method has its own strengths and weaknesses, making it more or less suitable for specific application. Bulk polymerization is suitable for step growth and chain growth polymers. Solution polymerization is ideal for application requiring polymers with a narrow molecular weight distribution such as high-performance plastic. Emulsion polymerization is suitable for application requiring quick production and easy processing. Suspension polymerization is suitable for application that require high conversion level. Gas phase polymerization is suitable for application requiring high-density PE products. And understanding this polymerization method is significant in the polyethylene industry as it enables manufacturers to choose the most suitable method for their specific application, leading to the production of high quality and cost effective products.